So you may have seen recently in a publication that it talked about these three dinosaurs that you had. One which was supposedly, dying, and then another one came to scavenge it, and then that got stuck in the mud and died, and then another one came to scavenge it and that got stuck. So you've got these basically three dinosaurs stacked on top of each other. And the idea is that it's a what's called a scavenge scenario, where you've got one dinosaur scavenge and another one come to scavenge that when that dies. Okay, how plausible is this? Well, it really links back to the mechanisms of the flood and how you actually got those dinosaurs there in the first place. Because this is where paleobiologists and paleontologists and geologists kind of diverge. Because what you have a lot of times is you'll have paleontologists, people who study fossils, especially paleobiologists, people who study how those creatures actually lived that turned into fossils. They tend to just focus on the fossils themselves. And then the geologists come along and just tend to focus on the rocks. And very rarely, surprisingly very rarely, do they actually have a discussion with each other. Okay, it does happen, but it's a lot of time people don't step back and look at the big picture, because what you look at the big picture is you actually find a history of geology which goes all the way back to the foundations of geology, which has given us a wrong idea of how rocks form. Now, Nicholas Steno, who was a Christian, he was a bishop, and he was a creationist. He believed in Noah's flood. He believed in the Bible. He tried to explain what he could see in the rocks. And he came up with what's known as the principle of superposition, which basically means that you've got these sediments were laid down here, and then these sediments were laid down on the top, and these sediments were laid down on the top, and then these sediments were laid down on the top. So basically, the sediments at the bottom are older than the sediments on the top. Okay, that's the principle of superposition in a very basic terms. Okay, and you can do, the sort of primary school experiment. You get like a glass of water, you pour in some sand, you pour in some stones, you pour in some mud, you pour in some leaves and stuff, you do shake it about, and then it will go into those layers, the heavier bits on the bottom. Yeah, well, it's all very good and well if the earth was a glass of water, but it's not. What you actually find is if you actually begin to study the oceans, and this is the other thing which a lot of geologists don't look at, you actually find that the only way you can get sediments, little bits of sand and mud, to move is in currents, in water flow. Okay? Now, if you have water flow, that means the sediments aren't falling that way. The sediments are moving that way. They're moving to the side. And you can have currents in the water. If anybody knows anything about, ocean currents and stuff, you can have one current that's going that way, one that's going that way, one that's going this way, that. They're all over the place, okay? That's why if you get into submarines, you try and find a particular current because one's travelling faster than another one. Well, if one current is travelling faster than another one, the size of rock that you can transport in a current is directly related to how fast that current is going. So if that current of water is going quicker, you can move a larger bit of rock. Okay, so what you actually find is a lot of these sediments were actually laid down going from side to side. So rather than that bit being older than that bit, you actually find that this side is older than this side because it's moving from the side. That's the only way you can get sediments being moved. And this relates directly in the rock, both in what you can see in the rock and what you can see in the fossils. Okay, so I can take you down to the south coast or to even up to among Wales way, and you've got these lovely big layers of limestone and shale. Alright, Jurassic limestone, and it's got some wonderful trees in it. And what you can find, you can simply do it, and you can do it yourself. You can go down on the beach and you can find these trees which are laying down. And what you do is you get a little compass and put it next to it, and you will find they are almost always pointing in a northeast, southwest direction. So you've got evidence of current being moved into this position. So you've got it moving from one side to the other, not being laid down like this. Now, linking back up to the dinosaurs, okay, and then moving on to the sort of the big picture of the flood sediments, if you actually look at those dinosaurs, one on top of each other, what you find is that they're not scavenging, they've actually been washed in, because you can see the currents in the rock which they're actually buried in. So you've got the currents in the rock, and the geologists go, oh yes, look, there's currents in the rock. You look at the dinosaurs, and the paleobiologists say, oh yeah, we've got one dinosaur on top of another dinosaur. How can we explain this naturally? That's the big problem. Well, if you can explain it naturally, scavenging is brilliant because it's a natural explanation. But how did they get there on top of each other, preserved like that, in rocks that show currents? Well, if the rocks show currents, that means those dinosaurs were moving in that current too. So what you have is a completely different scenario. Rather than these dinosaurs being scavenged, you've got these dinosaurs being moved in these great big currents until the current slows down, can't move them anymore, and boom, they get deposited suddenly there in a pile, one on top of the other. You're not looking at a life scenario. You're looking at a current being washed in and depositing them. Now, if you go back to the mechanism of the flood, Bible talks about it being raining for 40 days and 40 nights. Now, it can rain in places for 40 days and 40 nights, and you're not going to cover the world. Okay, that's why the Bible also talks about the fountains of the great deep, these great big water reservoirs underneath the earth's crust, bursting open and washing them over. Well, you've got these great big currents coming out. You've got your currents right there. They come out, they churn up lots and lots of this sediment, lots of the land mass is being churned up and moving across the earth in these great big currents, sweeping down, catching hold of these creatures and covering them. And then what you've got is, once all of the world is covered in water, which would have happened relatively quickly, you've then got all these currents still going on left, right and centre, gathering up all these sediments. Different speeds of currents carry different sizes of sediments. So a slightly slower one can take all the fine particles or the clays. A slightly faster one can take the larger sand grains. And you've instantly got the mechanisms not only to carry and deposit all of the different sizes of sediment and rock layers that we find around the world, but you've even got them all categorizing their fossils, sweeping them together and depositing them when they get a bit slower. And you'll find this all over the world. Flood deposits, you can just look at it. Wood pointing the same way. Dinosaurs, trilobites, all pointing the same way. All washed into one great big landmass. I mean, Dinosaur Provincial Park, you find literally thousands of dinosaurs all in one relatively small area. How do you explain that in a life situation? You really, really can't. Or you can try, but you really, really struggle to, because it's nothing like we ever see today. And then when you look at the fact that there are these currents running through the rock and all these dinosaurs have been swept up and then dumped in this great big basin full of this sedimentary rock, you're looking at a massive flood deposit. But we've got to get out of this thinking. Well, there's two things we've got to get out of thinking. First of all is that this layer is older than this layer, because nothing that we see actually shows that. You can only move sediments in currents. And every experiment that we've done about that shows, yeah, you can only move them in currents. So you've got to get into your head, these are moving in currents, and you've also got to get out of your head that these are not life scenarios. These are not ecological scenarios, because the minute that you begin trying to explain how these fossils got here in an ecological scenario, in the way that they lived, you just get a mess. I mean, we've got land plants living with sea creatures, if you want to take that. At what point did the sea creatures start running through the forests? Because you do, take the south coast, lovely great big pine trees, okay? Southern pine, or monkey puzzle tree as they're known over here. Lovely great big monkey puzzle trees, buried, all pointing the same way, next to some great big ammonites, the big curly-whirly ones. How do you explain that in a natural part of an ecology system? You don't. It's a mess. That's the one thing which you find studying paleobiology and paleoecology, trying to work out how these creatures lived. The one thing we know for sure, they didn't live together. But you've got them in a current, mixed together, being deposited together. This is not how they lived, it's how they died. If you can work out how they died, and you can work out that by looking at the sheer enormity of these deposits, it's covering most of the world. So you've got a massive deposit which is burying these creatures really, really quickly underwater. You're looking at a worldwide flood. There's no other explanation for it, and I will be dogmatic in that. There's no other explanation in how you can get these creatures mixed together and buried. It has to be a massive, catastrophic, worldwide flood, and we read about that in Genesis. It gives the perfect scenario. It doesn't just tell us about a worldwide flood, it tells us all about the mechanisms. It tells us the fountains of the great deep bursting open. It's wonderful because it tells you all the details that you need to know in order to be able to describe how it actually happened.